Let us now master the technique of implicit differentiation with 6 excellent test examples. I hope that helps. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss 3 questions which are based on implicit differentiation. These examples cover all the variety of questions which you need to understand for solving a problem based on implicit differentiation. Perfect? In calculus, this is a difficult topic and many students find it challenging to answer questions, and therefore we have the examples which are kind of simple to begin with and very complicated to end with. So half of these questions are actually difficult. We see such questions always in a test paper. Now, one thing very important to understand is that most of these equations do not represent functions, but they represent relations. I've given you a graph of one of these, which is actually question number 5. So you see, if you draw a vertical line, it will fail the vertical line test and it is not a function. And many of these, it is very difficult to isolate y. Well, clearly, for some you can easily isolate y, but for others it is kind of difficult. And therefore, implicit differentiation is a great way of finding derivatives of equations where isolating a variable, making it a subject is not important, right? Now let's see, how do we solve them? 6 of these. I'd like you to actually pause the video, try this solution, and then look into my suggestions. Also remember, in case you want to learn directly from me, you can always send an email on the address given. Most of my students are doing fairly well. Some are right there on top of their class, getting highest marks, awards, and scholarships like Akshit.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshit Kandilani.
Great. Our student Akshit gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. Now, let us begin with solution of these questions one by one. I'll take up question number 1 first. To begin with, we'll understand the strategy. So the question here is 3x squared plus half of y squared is equal to 5. We need to find dy dx basically, right? Derivative with respect to x. So let's find derivative with respect to x. So if I differentiate with respect to x, the whole equation on the left hand side, which is 3x squared plus half y squared, and also the one on the right hand side, we'll see what do we get. In short, this particular step which I've done, I will write this as differentiate with respect to x. You get the idea. So in short, when I say this, I will mean that differentiate both sides as I've shown you right here. Now using the properties of derivatives, we can differentiate each one of them. Now what is the derivative of 3x squared with respect to x? Well, we'll apply the power rule, right? As soon as you apply the power rule, you get what? You get 6x here, right? Plus derivative of half y squared. So half is a constant, 2y, and we still have to multiply by dy dx since y is a variable and not x in this particular case. You get the idea. Derivative of a constant is 0, and therefore we get 0 on the right hand side. As you can see, we have done the differentiation with respect to x. So once you do that, you can isolate dy by dx, correct? So let's isolate this. Well, let's simplify it a bit more. We can cancel the 2's. So you get y dy dx, correct? So let me rewrite this as y dy dx and take the other term, which is minus 6x, on the right hand side. So we get dy dx as equal to what? We get dy dx as minus 6x over y. So do you see how we could find the derivative dy dx without isolating y at all? Do you see that? This is what we call implicit differentiation. Is this process clear to you? Perfect. Simple question to begin with, and I hope you understand the concepts. Now we have a very similar question for you to do. So this time we have square root of x plus square root of y equals to 16. So let me rewrite the question here. We have square root of x plus square root of y equals to 16. Now some of you will write this as x to the power of half plus y to the power of half equals to 16, and then they will do differentiation with respect to x, correct? Let's do that. So that means we are doing d dx of square root of x. You may write x to the power of half, however, I prefer to keep it same. D dx of square root of y equals to d dx of 16. Now derivative of square root of x you've done so many times will be 1 over 2 square root x, right? And that of square root of y will also be 1 over 2 square root y. However, we have to still differentiate y with respect to x. So we write this as dy dx. Right hand side is a constant, and therefore we get 0. Do you see that? Very similar to the last question. And so now we'll have isolate dy dx. So the first term, which we'll now write here, is 2 square root y dy dx, and take the other term on the right hand side as minus 1 by 2 square root of x. Now multiplying both sides by the denominator of the left, we get dy dx, or you can isolate, right? So with a negative sign, 2 square root y over 2 square root x, right? 2 and 2 cancel, and you do get minus square root of y over x, right? So we find our answer dy dx as equal to negative square root of y over x. Perfect. So we have done differentiation of this particular function without isolation, right? You could have isolated and done this question also. So that is a starter for you. Here, what do we have? Now we have an equation of a circle, which is x squared plus y squared minus 6x plus 2y equals to 15. So let us write down the derivative of this equation. So the equation is x squared plus y squared minus 6x plus 2y equals to 15. I would like you to pause the video, answer this question, and then look into my suggestion, right? So we are differentiating with respect to x. So what do we get? We get 2x plus 2y dy dx, right? Minus 6 plus 2 dy dx, correct? Equals to 0. Constant derivative is 0. Now, you have two terms where dy dx is there and the other two terms where dy dx is not there. So what we do here basically is we can take these two terms on the left, the others on the right hand side. So we get 2y, and here we get plus 2. Let me write dy dx first, and then we'll isolate and then factor, correct? Plus 2 dy dx equals 2. Taking these terms to the right, we get 2x plus 6. Is that clear to you? Now we'll take dy dx common, and 2 times dy dx we could take common, and we get y plus 1, right? So we get 2 times dy dx common, and within the factor we get y plus 1. equals to minus 2x plus 6. And so we can write dy dx is equal to what? Dividing them by 2, right? So when you divide them by 2, we get minus 2x plus 6 over 2 times y plus 1. Clear, right? So 2 and 2 cancel, so we get minus x plus 6 over y plus 1. So that becomes our answer for dy dx. Is that clear to you, right? So we get our derivative, and this time the derivative is, let's write down clearly here, dy dx is equal to, you could also write minus outside. You get the idea? Minus x minus 6 over y plus 1. Make sense? So that is also correct. So either way, you could write down the answer of this particular question. Is that clear to you, right? So in the first 3 questions, you have seen how easy and simple it is. Question number 4, let's differentiate with respect to x, right? So we have the question x to the power of 2 by 3 plus y to the power of 2 by 3 equals to 1. Now we're going to differentiate with respect to x. So we get 2 by 3 x to the power of 2 by 3 minus 1, which is minus 1 by 3, right? X to the power of minus 1 by 3. Now I'm directly writing these derivatives at this stage, since most of you are very familiar with the power rule, right? So I think you know what is power rule, right? So in all these examples, we have applied power rule, correct? And now what do you get? We get plus 2 by 3 y to the power of minus 1 over 3 dy dx, correct? Equals to 0. Perfect. So that is what you get. When you say minus, that means that x is coming in the denominator, right? Perfect. Okay. So we can take dy dx and then isolate it. Perfect. So we can cancel 2 by 3's, right? So we could write this as 1 over cube root of x. Makes sense, right? Cube root of x. 2 by 3 I'm cancelling. Plus 1 over cube root of y dy dx equals to 0, correct? So what I did was that I cancelled this, dividing both sides, because here it is 0, right? Okay, now we can rewrite what is dy dx. Taking this on the right hand side, let me add one more step here. 1 over cube root of y dy dx equals to negative 1 over cube root of x. So dy dx is equal to negative, and we'll multiply this, right? So we get cube root of y over cube root of x. Make sense? You could also write this as dy dx equals to negative cube root of y over x. So that becomes the derivative. So you see how we have found dy dx very easily using implicit differentiation. Perfect. So I hope it makes sense. So the question is 2 times x squared plus y squared whole square equals to 25 times x squared minus y squared. That's a relation given to us. We need to find dy dx. Well, this is a very interesting relation whose graph will be like shown here. It is really not a function, it is a relation, and kind of difficult to isolate y from this particular relation. Implicit differentiation is the perfect way of finding the derivative with respect to x for such relations. Let us see in this video how do we do it, right? Well, in case you want to learn from me, you can always send an email on the address here. Most of my students are doing fairly well. Some are right there on the top of their class getting awards and scholarships like Akshat. Now, let us see how do we solve this question, rather find the derivative dy dx. The question is 2 times x squared plus y squared whole square equals to 25 times x square minus y square. Now, if I differentiate with respect to x on both the sides, what do I get? Well, let's apply the power and chain rule, correct? So we'll apply power and chain rule, right? So what we get here is 2 times x square plus y square to the power of 1 times d dx of inside function, right? On the right hand side, we get 25 times derivative of x square is 2x and that of y square is 2y dy dx, correct? Okay, so let's simplify, find the derivative of x square plus y square. So we get 4 times x square plus y square times derivative of x square plus y square is 2x plus 2y dy dx. That is implicit differentiation. And on the right hand side, if I open the bracket, I get 50x minus 50y dy dx. So I hope this step is absolutely clear. You can take a moment, try to understand what we have done here. And now the idea is to figure out what is dy dx. So the term involving dy dx, I like to keep it on the left hand side and rest on the right hand side. So on the left hand side, I get 4 times x square plus y square times 2y dy dx. I'm keeping this on the left hand side, right? Well, I could divide by 2 and simplify. I could do that. Let's do it later. So we get, when I multiply, I get 4 times 2 as 8y, and we have x square plus y square dy dx, right? And I'm bringing this term on the left hand side as plus 50 y dy dx. Do you see how we are trying to simplify the expression? On the right hand side we have 50x, and I'm going to take 2x times 4 times x square plus y square also on the right hand side. So it becomes minus 8x times x square plus y square. Does make sense? So I purposely did not simplify it so far, kept the numbers as such, so that it becomes easier for you to understand what we are trying to do. Now here you can see we can take 8y dy dx common, right? And then simplify. But let me now divide everything by 2. So 2 is a common factor. So I'm rewriting this as 4y x square plus y square dy dx plus 25y dy dx equals to 25x minus 4x x square plus y square. Correct? So in dy dx, we have 4y times x square y square and 25y as common, right? And right hand side has all these terms, right? So we'll take these terms to the next page and then do it. So on the left hand side, we have 4y times x square y square dy dx. That's my first term. Second term is plus 25y dy dx. Equals to 25x minus 4x times x square plus y square. Correct? So we can take dy dx as common. So we're left with 4y times x squared plus y squared. Let me open this bracket and write down 4y x squared plus 4y cube, and here we have plus 25y. On the right hand side, we do have x common. I could take that and write the terms as 25 minus 4x squared minus 4y squared. Is that clear to you? And now we can write down dy dx as equal to ratio of x times 25 minus 4x squared minus 4y squared over all this, which is 4yx squared plus 4y cube plus 25y. You see that? Solution is easy to understand. At the end, we can also take y as a common denominator. So we have x into 25 minus 4x squared minus 4y squared over, we can take y common here. So we get 4x squared plus 4y squared plus 25, correct? So if you want to write it in a very similar way, you can see what dy dx is, right? So dy dx can be written as x over y. Now here we have 25 minus 4 common, right? And within brackets we have x squared plus y squared. And in the denominator we have 25 plus, we have 4 common, x squared plus y squared. You get the idea. So very similar expression is there, and that becomes the derivative of this particular function. Perfect. So I hope it is clearly understood that when we do implicit differentiation, the process involves factoring and rearrangement of the terms, which could be tricky at times. I hope with this example, the strategy is absolutely clear. So here is the last question, question number 6. X to the power of 4y cubed minus y squared over x squared equals to 4y. We need to find dy dx. Product rule and quotient rule, both will be applied to find the implicit differentiation in this particular case. So straight away, let's differentiate with respect to x, right? So if you do that, what do we get? We get 4 times, I'm trying to save some space here because it's going to be lengthy, right? So we are differentiating with respect to x. So you get 4x cubed, applying the product rule, right? Times y cubed plus x to the power of 4 times derivative of y cubed, which is 3 times y squared dy dx, correct? Minus, apply the quotient rule. So x to the power of 4 comes in denominator. Derivative of y squared is 2y dy dx times x squared minus y squared times derivative of x squared, which is 2x. Let me write here 2x times y squared equals to derivative of 4y, which is 4 dy dx, correct? So you see that we have 3 terms here which have dy dx. We need to club them together. Also, we have a denominator, x to the power of 4. So if I multiply every term with x to the power of 4, I can simplify it a bit, right? Well, in this case, x squared over x means we have x cubed here, right? In a way, right? So we could actually simplify and then do it, or later we can cancel x, right? Anyway, so if you want, we can write this as, so let's multiply everything by x cubed because one of those x will get cancelled. Is that clear to you? So if I cancel, I get x cubed here, and this becomes x and that becomes y squared, correct? So let's multiply by x cubed, all these terms, and then see what do we get. So I'm using a different ink. So multiplying by x cubed, we get 4 x to the power of 6 y cubed plus x to the power of 7. 3 is the number. Let me write 3 before it. Y square dy dx, correct? Open the bracket. Minus 20y x y dy dx. Clear? One of those x cancelled, right? And then here we have this x cancelled, so minus 2y squared. Minus and minus becomes plus. Equals to 4 dy dx. Absolutely clear? Now let's take dy dx and write down all the terms which have dy dx in it. So the first term which has dy dx is 3 x to the power of 7 times y squared. The next term is minus 2xy. We'll bring this 4 to the left hand side, so minus 4, right? All those terms which do not have dy dx, I'm taking them on the right hand side. So we get minus 4 x to the power of 6 y cubed. Then we have minus 2y squared, right? And so we can write dy dx as equal to, well, we can say minus outside. And we can write 4 x to the power of 6 y cubed minus 2 y squared over all this, which is 3 x to the power of 7 y squared minus 2xy minus 4. Make sense? So that becomes the derivative of the given function. Perfect. So that is how we are going to use implicit differentiation to find dy dx in given relation. So I hope with this, the solution of all the 6 questions is absolutely clear. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. And in case you want to learn from me, you can always send an email on the address given. Also, contact us on the website for more information. Thanks for your time and all the best.